So if you're going to complete the square, the basis of it is we want something to look like this. We want to create these perfect squares. Now, you should have a little bit of an idea why we would want to create perfect squares, because the equations we were solving before this were perfect square equations. So the general idea is I'm going to use this technique to solve some more types of quadratic equations. So what can I do with x plus a all squared? I can write it 2 times. So it's 2 factors of x plus a all squared, x plus a times x plus a. What can I do with x plus a times x plus a?
Take one out.
Distribute it out, FOIL it. You're going to get x squared
Plus ax plus
Yeah.
ax plus a squared.
So if you have ax and ax, you get
2ax.
2ax, so plus 2ax. And then finally plus a squared. So if I have a polynomial that looks like that, it actually factors into a perfect square. Great. The thing is, what happens if we have x squared plus 2bx, and I'm looking for the number that needs to go in that last spot to make it a perfect square? So what do I need to do? Well, up here it's 2a in the middle and a squared at the end. So I definitely don't want the 2 around. So how do I get rid of the 2? It's 2 times a. How do you get rid of 2? Divide by 2. So take 2b and divide by 2. So divide by 2. That'll give you b. Okay, great. At the end is a squared. So what should I do with the b? Squared. So if I square it, we're going to get a positive b squared. Does that make kind of sense? So you take half of the middle number, gets rid of the 2. That number becomes a perfect square, and it fits perfectly there at the end. What are factors of b squared that add up to 2b? Well, b and b. So it's going to work out rather nicely.
But where's the x?
I don't care about the x. See, the last term is not anything to do with x.
Okay.
So if you want to think about it, you're divided by 2x.
Okay.
But usually I just look at the coefficient divided by 2. All right, so if I have numbers like x squared minus 6x, and I'm trying to create that last number to make it a perfect square, you're going to follow the pattern. The first step is take the middle coefficient, which is negative 6, take half of it. What's half of negative 6? Negative 3. And we do want that sign. It actually becomes kind of important in our answer. And then we're going to take negative 3 and square it. What's negative 3 all squared? It's a positive 9. What are factors of 9 that add up to negative 6?
3.
What kind of 3? What kind of 3?
Negative 3 and negative 3.
So this becomes x minus 3 all squared. So creating a perfect square. These are not equations. These are expressions. I'm not solving anything yet. All right. What if I have x squared plus 8x, and I'm looking for that third number? The pattern doesn't change. Half of 8, half of positive 8, I really should say, is positive 4. Square positive 4, it's going to be a positive 16. What are factors of 16 that add up to 8?
4 and 4.
4 and 4. So this becomes x
Plus 4
plus 4
squared.
all squared. That's a neat trick. Okay. So what happens if we have x squared minus 5x? What's different about that one?
No, I don't want 2 point. Not a whole number.
It's not an even number, so it's not going to be divisible by 2. So this is what we're going to have to do with it. What's half of negative 5? And I literally mean 1/2 of negative 5. Don't say 2.5.
2.5.
Don't say 2.5.
2.5.
That's a mixed number. I don't deal with mixed numbers.
5 over 2.
5 over 2. So this would be negative 5 halves. You're going to have to with this one. Now, if you get confused with this, just go off to the side. It's 1/2 times negative 5. How do you multiply fractions? Well, first of all, you put a 1 under the 5, and then you go straight across. So it's negative 5 over 2. And that becomes kind of simple. Square negative 5 halves.
25th fourths.
20,
Negative
25 fourths.
25.
Is that 25th fourths? 25 fourths. So it's a positive
Tomato, tomato.
25 over 4. Now it gets a little trickier. What are factors of 25 over 4 that add up to negative 5? Well, there's a little clue here. This number here is negative 3. This number here is also negative 3. This number here is positive 4. This number here is positive 4. So when I get here, I'm going to go x and just dump that right in here. Negative 5 halves squared. I don't even have to think about it. It's a pattern that gets evolved. All right. Not that bad, right?
Not yet.
Okay. No, it actually doesn't get much worse than that. Not much. So let's see how we're going to solve this. So solve quadratic equation by completing the square. Now, this technique, completing the square, gets used in a lot more different places than just solving a quadratic equation. If you ever get to it, parabolas, hyperbolas, circles, it gets used a lot for those. But for our purposes, we're just trying to solve quadratic equations. So if I have x squared plus 2x plus 3 is equal to 0, and I want to solve this, there's actually two ways to try first. Well, one way, technically. Are there factors of 3 that add up to 2?
No.
No. The only factors of 3 are 1 and 3, and they add up to 4. And we're used to just call this prime, and we would go on our merry way and say there's no solution we can find. But by completing the square, I can actually solve this thing. So you start off by creating the space to the right of it. We need a space here to put a number. So what can I do with the 3?
Subtract it.
Put it on the other side, yeah, get it out of your way. But leave a space here, just leave a space, equals negative 3, because you know you're going to put a number there. All right? And then you just follow the pattern. Half of 2, this positive 2 is what?
1.
Positive 1. Square positive 1 and you get positive 1. Now, what's different between solving an equation and messing around with an expression is this. Whatever you do to the left, you also have to do to the right. I just added 1 to the left-hand side here, so I better come over here and add 1. Otherwise, it would be an unbalanced equation. It wouldn't be the same type of equation. All right, what happens to the left-hand side? Well, the whole reason for doing this is to create these perfect squares. So what is this as a perfect square? X plus 1. Remember, this number just gets dumped right down in there. Squared is equal to? Negative 2. Yay! And now what are we into? We're into a perfect square equation. How do I solve a perfect square equation? Take the square root of both sides. That's a mental step. You don't have to show the square roots. It's a mental step. You better do the second step right, though. It's x plus 1 is equal to... Nope. Plus or minus. Don't forget that. That's the hard part that people seem to have. What's the square root of negative 2?
They can't.
Yes, you can.
It's negative.
Didn't we have a whole section on how to deal with this? Yes, that's an I. So you can pull out an I because of the negative.
Yeah.
And then left behind is the square root of 2. Remember, if you see square root of a negative, automatically you're looking at an I. You can pull that out first and then simplify the radical second. All right, last step.
Subtract that 1.
Yeah, I'm trying to solve for x, so get rid of the 1. So this becomes x equals...
1 plus, or 1 minus. Negative 1 plus or
Negative
minus.
1 plus or minus I square roots of 2. Yay! Except, that's not the answer. You gotta split it. So the final answer is going to be x is equal to, you don't have to put the squigglies, but I'm a squiggly fan. That's a set solution. Negative 1 plus I square roots of 2, comma, negative 1 minus I square roots of 2.
So the plus or minus is not going to be efficient.
a shortcut, and it allows you to write things concisely. But if you talk about notation for a second, I saw several of you having problems with this in the lab. A lot of you want to leave things that look like this, and you have to look at it the right way. You can't leave it looking like this. So I just want to talk about simplifying these types of expressions so that you don't screw up and get weird answers. When you see something like 2 plus or minus 7 over 3, you have to separate it. So that would be 2 plus 7 over 3 and 2 minus 7 over 3. Agreed? Okay. You can't leave it like that because anytime you leave an expression in math, it has to be in simplest form. You can't leave square roots of 8s around. You can't leave 3 over 6 around, and you definitely can't leave 2 plus 7 over 3 and 2 minus 7 over 3. You have to simplify it. So 2 plus 7 is?
9 over
9. 9 divided by 3 is? 3. 2 minus 7 is?
Negative 5.
-5 over 3. And you can't do much with that, so just leave it as -5 over 3. The other danger is if you end up with an answer that looks something like this. 8 plus or minus 6 square roots of 3 divided by 4. And I saw some people yesterday, oh, 4 goes into 8 too, so it's 2 plus or minus 6 square roots of 3. Yeah. Highly suggest you split it into 2 pieces, so you get 8 plus 6 square roots of 3 over 4, and 8 minus 6 square roots of 3 over 4.
Too much paper.
I know, but life goes on. These are not linear equations anymore. Divide everything by 2, not just one of them, all of them. So 8 divided by 2 is? 4. 6 divided by 2 is? 3 square roots of 3. And 4 divided by 2 is? 2. That's the answer. You have to do it to all of them or none of them. It's an all or no. What?
Why do you divide by 2?
Because they all have a common factor of 2.
Okay.
I mean, another way of looking at it is what's the GCF of the top 2? 2. So if you pull out a 2, what's left behind?
4 and 3.
4 plus 3 square roots of 3, right? All over 4. That's where the simplification's happening. But you can think of it as distributive-wise, you have to get rid of it in all of them. Or you can think of it as factoring-wise, and then you only have one thing to reduce. Either way works perfectly fine. And the only reason I talk about that is that's where weird mistakes start happening. People start canceling through addition and subtraction, or not combining them properly, or not simplifying them properly. You got to be a little cautious on those. All right, so let's make this completing the square slightly worse. For example, x squared minus 7x minus 3 is equal to 0. By the way, if they're not equal to 0 to begin with, get them equal to 0 first, and then decide on how you're going to solve it. There's several techniques to use, so the best thing to do is get it equal to 0 first and then decide. Unless you can tell that it's a perfect square right from the beginning. Are there factors of 3 that subtract up to 7? Nah, I can't think of any. So we're going to do this by completing the square. So we're going to go x squared minus 7x, leave a space. In other words, just put the equal sign exactly where it was to begin with. Bring it straight down. And then on the other side, it would be equal to positive 3. Don't forget to change its sign. You're moving it across the equation. All right. And then just follow your procedure. Half of negative 7. In fraction form. Negative 7 halves. Negative 7 halves. Okay. Square it. Negative 7 halves squared. Positive 49 fourths. Oh no. Oh well. But if you add 49 fourths to the left-hand side, you better add it to the right. And then you have to work with fractions. How horrible. That's life. How do I add 3 and 49 fourths? Common denominator is 4. Oh, by the way, we need to do it this way so that you'll understand what I'm going to do to you at the end of the class. So we're going to work this without calculators. So if I multiply the bottom by 4, what do I have to do to the top? Multiply by 4. So this is really 12 fours plus 49 fours. Okay. Oops. Once you get to there, the rest of it is kind of easy. The left-hand side, what does all this become? X minus 7 over 2 all squared is equal to 12 fours plus 49 fours. 61 fours.
I have a question.
Go for it.
Why was it a negative 49?
I added 49 fours here. Why did I add it here? Because it's the square of 7 halves. The negative is irrelevant when you square it, it becomes positive. So if you add something to the left-hand side, you better do the same thing to the other side. It's got to be balanced. All right, what do I do to both sides? Square root. So you can do this in your head, but I like putting the symbol on here. And the left-hand side becomes? X minus 7 halves is equal to plus or minus square root of 61 over 2. Because the square root of 4 is 2. Remember, you can separate it. It would be square root of 61 and square root of 4. So square root of 61 over 2. Perfectly fine to simplify the radical. Okay, cool thing. This doesn't always happen, but for the most part it does. These two have the same denominator. That makes your life easy. There's a few cases where they don't, and you have to mess around a little bit. But you don't have to if you don't want to. You can leave them as two separate terms, but people get confused by that. So here they have a common denominator. What am I going to do to the negative 7 halves? Now when I add it across, it has a common denominator of 2. I don't have to worry about the bottom. All I have to worry about is the top. So the negative 7 becomes positive 7. It's still plus or minus, and it's still the square root of 61. Does 61 break down? I don't think it does. I think it's prime. So your final answer would be 7 plus the square root of 61 over 2, 7 minus the square root of 61 over 2. And there you are. Ta-da! Now, since you all have calculators, tell me the decimal answers. The approximate answers. Go ahead, type them in. I want to see if you can use your calculator. Do you have one? I know you just said you didn't.
What you want us to do?
The first one will be fine, and then we can do the second one afterwards. So 7 plus the square root of 61. Shouldn't take you that long. What'd you get? 7.4. If you didn't get 7.4, you tried to type the whole thing into your calculator, and therefore you got it wrong.
I did.
If you type the whole thing in your calculator, this is what's happening. You're doing 7 plus the square root of 61 divided by 2. Your calculator understands the order of operations. So the first calculation it's going to do is the division. You get an answer for that, and then add it to 7. But that's not what you want it to do. So if you want to type it all in one line, you have to put parentheses in front of the 7 and after the square root of 61. You have to have 2 after the square root of 61. So if you want to type it all in at once, you would just type this in. The good thing about typing it all in at once is then you can use your up arrow, go through, change the plus to a, and then just hit equals again. So all I have to do is go up and change that to a minus, and the other answer would be negative 0.4. So this one gave us, oh, I forgot now. What the first one gave us? 7.4. And the other one gave us negative 0.4. Now these answers are approximate. They're not exact because you're taking a radical and rounding the answer to the nearest tenth there. But there are reasons that you would need to be able to get decimal answers. Because one of the more famous problems would be, how long was the object in the air? What? This formula is a wonderful thing for figuring out how long something's in the air. And you would have to say, well, it was in the air for 2.3 seconds. or whatever it is. Of course, this one doesn't work really well because it's very light. And it actually slows it down a bit.
That's what I do. I'll just throw it and then count until.
1 Mississippi, 2 Mississippi, 3 Mississippi.
Woo! Bouncing off the CD, it goes faster. Oh well. I threw this at someone the other day. It didn't get to him. Yeah. Okay. Can I make it harder? Yeah. Ooh. The only way to make it harder, let me make sure that the book does it. Yeah, they do it. Is to write something like this down. 2x squared minus 6x plus 1 is equal to 0. Why is this harder? What's different? At 2. You cannot have a lead coefficient of 2 because this completing the square is based on a lead coefficient of 1. So we have to get rid of the 2. So how do we get rid of it? We're going to divide it away. But if I divide it away from here, where else do I have to divide it away from? Everything. Literally. You're distributing it across the entire equation, dividing everything by 2. Totally legal because you're doing it to both sides. So that'll give us x squared minus 3x. What should I do with this plus 1/2?
Try
The
it
other
out.
side.
Drop it off on the other side, so it equals
Negative 1/2.
negative 1/2. Okay. And remember, leave this little space here. Just bring the equal sign straight down. Okay. So that's the first thing. You can't have a lead coefficient other than 1. So you divide away whatever's in front of there. Second thing, go back to completing the square. Half of negative 3? Negative 3 halves. Square it.
6.
She said 6 inches. 9/4. And if you add 9/4 to the left, add 9/4 to the right. Okay. So what does the left-hand side become?
X plus 9 squared.
Nope.
Yes.
I mean, x minus 3 halves.
It's always that half number. That's why I like writing it down. So it's x minus 3 halves, all squared, is equal to, common denominator?
4.
4. So I have to multiply top and bottom by the 1/2 by
2.
2. So multiply by 2. So this is negative 2/4 plus 9/4. 7/4. So this side becomes 7/4. Square root. Whatever I do to the left, I do to the right. Okay. So x minus 3 halves all squared, square rooted is x minus 3 halves is equal to. Nope. Plus or minus the square root of 7/2. Again, this is a nice one. They have that common denominator. So we move the 3 halves across, and we're going to get x equals something over 2. What goes on top?
3 plus the minus square root of 7.
So that would be 3 plus the square root of 7/2, and 3 minus the square root of 7/2. Yay! Oh, we got time. Does it get worse? The only way I can make it worse is this. And it's not much different than that last one. Oh, let's go horrible. 5x squared plus 3x plus 4 is equal to 0. That's worse. First step, divide by 5. Divide everybody by 5, including the 0, to be proper. Okay. So that brings our equation down to x squared plus 3/5 x. You want to make sure you separate it. You want a coefficient. And then move the 4/5 to the other side so it becomes negative. Okay. And then just go through your method. Half of 3/5. 3/10. If you don't see that, go off to the side and say 3/5 times 1/2. 3 times 1, 5 times 2, 3/10. So this is 3/10, positive. Square it. 9/100. So we're going to add 9/100 on this side. We're going to add 9/100 on this side. Ooh. Yeah, that's hard. Let's work with the easier side first. Left-hand side is x plus 3/10, all squared, is equal to, common denominator,
Hold on, I know what it is. 71.
Hmm?
Hold on.
What's the common denominator?
100.
100, so I have to multiply top and bottom by 20. 4 times 20, of course, is negative 80 over 100 plus 9/100. So the final answer is
36.
negative 71/100.
I see, I just said.
All right. Negative 71/100. I'm a stickler for showing my work though. And there's a reason, because what's going to happen after this one, you're not going to be able to use calculations. All right, what do you do next? Square root both sides. Left-hand side becomes x plus 3/10 is equal to
Plus or minus I squared root of 71.
I square root of 71 over 10. Over 10. Might as well simplify that square root of 100. And again, nicely, for some reason, I usually end up with one where the denominators are not exactly the same, but so far they're showing up exactly the same. And then finally, common denominator is 10. On top is
3. 3 out.
negative 3 plus or minus I square root of 71. I'll just leave it like that for now.